Now, in our next topic, I'm going to tell you a little bit of an interesting trick of how we can essentially use our Smith chart to immediately calculate not simply impedances, but admittances as well. And that trick is based on this very familiar equation that we have derived, which is the equation for the lambda by 4 transformer. So if you just assume that I have a load ZL connected to a transmission line whose length is quarter wavelength, lambda by 4, and I basically look at the impedance at the input Zin, then I have actually already derived this expression that impedance Zin is equal to Z0 squared divided by ZL. Now, if I write this slightly differently, so if I take one of those Z0s and put them in the denominator, that is equal to Z0 divided by ZL over Z0. And of course, I have already found out that this ZL by Z0 is equal to my normalized little ZL. And that is interesting because if you look now at my normalized input impedance, little Zin, this will be equal to the, of course, Zin over Z0. And if I use the expression of Zin from above, this will end up equal to 1 by ZL, which really is very interesting because this is equal to YL. So in other words, what this equation basically says is that if you use a lambda by 4 transformer with a little ZL of normalized load, then what you really have at the input, just as a calculation, is equal to YL, the normalized admittance of the load. And so, as we know, a rotation on the Smith chart of lambda by 4 is basically equal to 180 degrees. So if I consider any load on the Smith chart, then I basically am able to calculate the impedance simply by taking the antipodal point of this load. Let me pick a quick example here. So if my ZL here is equal to 2, and I ask the question, what is the admittance of that? Then we all know that the admittance should be equal to 1 by 2 or 0.5, which is obviously a very simple thing to do. But you can also do it from the Smith chart simply by taking the antipodal point and landing here. So that would be the YL equals of basically 0.5. And that's true for any point on the Smith chart. You can take this point on the Smith chart, take the antipodal point, and immediately calculate, if this is your ZL, what is your YL. Which basically means that you can use the Smith chart to deal not just with impedances, but to deal with admittances as well. So the Smith chart suddenly becomes an amazingly useful admittance tool in addition to being an impedance tool. This is another example of a load of 0.5 plus j 0.5, essentially landing to 1 minus j if you just want to do the YL.